Good afternoon. I'm Manu. So I work with NumFOCUS as introduced. So I'll be going to give a talk about real-time context engineering for LLMs. So what is context engineering? Why is it popular now? Why not call it prompt engineering? Like, what is context and what is happening? So like, the concept of context engineering comes from something called in-context learning. In-context learning is this uh, new type of new class of machine learning in which like LLMs can learn on the fly during inference based on some examples that we have. So it's slightly different from classical machine learning algorithms like supervised and unsupervised learning in the sense that it allows you to uh, it allows you to make an LLM learn on like data that it has never seen before. So how do you do that? You do that by providing examples. For example, you have, if you want to classify a stone into Lumerite or Zernite, then you can provide some properties to it. So you can give a set of examples to a large language model and tell it to predict, let's say, if a new sample that it sees has been, is actually what it is. It's basically a binary classification problem. Then a large language model usually can learn from the data that it has in the context, and then it can interpret the data. So what does this really help us with? So in any applications that you are using LLMs, that is, any application using LLMs can actually use data that can still infer from data that it doesn't have in its training data set by providing a specified subset of data by injecting a specified subset of data into a prompt. So this specified subset of data is something similar to what we do for features. So we engineer, for classical machine learning, we have raw data that we do some processing on to actually get a normal feature. So this is somewhat similar in the sense that you have some raw information. You do some processing on it to get the context or a prompt that can be injected into the prompt to make an LLM perform better on like raw data, like on some particular tasks. So that is basically the concept of in-context learning. Context engineering makes use of in-context learning to provide better responses and make your LLM applicable for real-time AI applications. In-context learning is a really strong paradigm. Like it is the way in which we can make LLMs actually applicable for real-time AI systems. And it also is much cheaper than alternatives that you have. Fine-tuning LLM is very expensive. It is a time-consuming task in which a lot of it takes a lot of time, and but in-context learning gives you a very cheaper alternative in which you can integrate a lot of integrate like real-time data into it, and like data that the model has not been trained on. So in the context of like now let's move on to an agent. What is really an agent, and what does it have to do with context engineering? An agent, you can think of an agent as a conduit that can be used for injecting context into a prompt. So an agent basically uses a protocol like MCP to fetch data from servers like fetch data from context data from different sources and inject it into a prompt template to actually perform a particular task. The context data can be also thought of as being like two major types. Context data can be private data. Private data is something that you never want your LLM to be trained on. Like it's basically private to you. But context data can also be things like application data, like things that that things or events that happen real time. So if you look into a few examples of examples, we can one really cool example is of AI system that uses agents using private information as context is Klarna. Klarna is basically a fintech company in Sweden that provides buy now pay later services. So Klarna's customer service agent basically handles more than like 65%. This is a blog post that they have done a couple of times back. And like if an agent actually wants to perform customer service, then it has to have access to information that relates to a user. And LLM, hopefully never, would be trained on user data. So one way of making an LLM use this data is by injecting the data into its context. And this is one really cool use of context engineering. And another really, a really cool way in which context data can be, one reason why context data can be inserted is for real-time use cases. Real-time events happen all the time, and if you actually need that data to be, if you need an agent, the real-time agent, basically to make meaningful predictions on for any use case, then you would have to have that agent make use of data that is available real time. So, for example, in the case of a TikTok-like agent, then the agent has to, the recommender actually needs to know the clear number of clicks, what is trending, and things like that, which is only available at that moment. That should be known at that moment. So context engineering is one way to integrate real-time data also into like an application. One more thing when we consider real-time applications is that the latency is very important for real-time. If any application is like greater than like 50 milliseconds, you think that it's slow and like it's not really useful. Yeah. Now any AI application that we have can be split into feature, training, and inference pipeline. Basically, 3 modular pipelines that can be used to generate features, train models, and create and deploy inferences. So how does this plug in with agents and like context engineering in general? If you think about context engineering is very similar to feature engineering in the sense that you have some data that you have to process and put in particular ways so that an LLM can access it in some way. So a feature pipeline is very similar to a context engineering pipeline. And then you have a training pipeline that is basically a fine-tuning pipeline in this case, which is optional. You don't always have to fine-tune things. But for some cases, like it might be helpful to fine-tune things. And then finally, you have an inference pipeline that usually contains LLM along with the context information. So in this case, like the inference pipeline is basically your agent that deploys and works for you. An application that uses an agent that makes use of context information that we have created in the pipeline. So, so there can be like multiple types of context information that can be available for like LLM applications. You can have unstructured data, like you can have unstructured data like documents and documents. You can have structured data that are data stored in tables. So we'll look into it a little bit more detail. We'll have a look at how structured and unstructured data, how an LLM application can be designed for structured and unstructured data. So in the case of an application, in general, we have an application always has a state. It has a user ID. It has session IDs. It has other information that usually gives a state of the application. And then it usually has application DB2, database 2. And by default, if you want to do, let's say, if you want to handle unstructured data, then the vector embeddings are the usual way to go. So you would have a pipeline that creates this embeddings from unstructured data and writes it to vector DB. And the application basically sends a query with some request to an API server that is running the agent. And the agent then uses MCP to query the vector database and create the complete prompt. The completed prompt is then sent to LLM, and the response is retrieved to create a response for the application. But like, what happens in the case of like structured data? Structured data there is one simple way to handle structured data is to just create the context in the application itself using the data available in the application. But this can increase the complexity of the application quite a lot. You could have the application developer might be able to pipe code it, but you never know. It might not be possible. It might be possible. But is there actually a better way to do it instead of just doing everything in the application? Well, we think there is. One approach you can take is to integrate a feature store to it. So a feature store would, in this case, would act as an interface between your application and your agent. So you could have a batch feature pipeline that reads data and keeps writing it to the feature store. And then you could have your agent that uses an MCP to query data from the feature store. And one very interesting thing that helps in this case, especially for structured data, is the state of the application that you have. The application state has information regarding user IDs and session IDs and any other keys that you have. And you can send these keys as part of your request to the agent to make the agent actually easily query data from the feature store. And you will be able to create a very curated prompt based on this information. Now, if you look into it a little bit more in detail, there is something else we can do to improve it even more. We could decompose one application into a set of tasks. Each task basically can correspond to a set of application IDs. So a set of IDs, basically, sorry, not application IDs, IDs. So then when the application basically wants to send when the application sends a request, it would send along with it all IDs that are required for a task. And this would allow the agent to easily query from the feature store and create the context based on data that it retrieves. And this can be done for all tasks. And decomposing an agent into a set of tasks allows you to have fine-grained control on what you have for on how you develop the context that you are using for prompting. In the case of real-time applications, what you can do is you can have a streaming pipeline instead of a batch feature pipeline that writes things directly to the feature store to allow for fresh features for feature retrieval. And so what is context engineering? Basically, context engineering can be decomposed into two modular systems of context pipeline or a feature pipeline that keeps writing features or context, that prepares context and writes it to the feature store, and an agentic system that basically makes use of the same context, that makes use of the context written into a feature store to generate predictive responses. And like just putting everything that we have discussed together, we have an application that has state informations like user IDs and like session IDs. You have an application database that stores some historical information from the application. You have the agent basically interacts with the LLM using some prompt templates that we have designed. It fetches context information using an MCP server or MCP server. And the context can be from different sources. For unstructured data, it can be from a vector database. For structured data, it can also be by using tools to query data from external web sources, or it can be from a feature store. And from a feature store, in case you have structured data. So feature store, the greatest advantage a feature store provides is that you could query data based on identifiers for tasks. And the data can be also like streaming. The data can be written using streaming pipelines or batch pipelines. One more thing that you can do is like you can write traces that can be used for monitoring and observability of your LLM applications right into the feature store itself. Monitoring and viewing observability and monitoring of LLM system is also really critical, and a feature store helps you do that too. And now moving on to real-time context engineering. So real-time context engineering is basically nothing but using a streaming pipeline along with agents. So one really important concept for feature freshness, for streaming pipelines in general, is feature freshness. So feature freshness is the time between a feature is actually created from the event source to when it is actually available for read from your feature store. And for real-time AI applications, this is really important in the sense that you can't have stale features. Stale features leads to non-optimal predictions, and fresher features usually lead to better performance. And like this, let's consider like a example of TikTok-like application, and how we would have to architect it so that we we can make it agentic. So the feature pipeline is basically composed of Apache Flink. So we have event data from like multiple sources coming in, and mostly it is through Apache Flink, and we have embeddings that can be written through like PySpark vector embeddings. And then you have a recommendation system using any of the two-tier models, and then you have an inference pipeline that combines the recommendation system with the agentic system. And this would finally give you the video player that you have for personalized recommendations. So the application by itself would be we have a repository that you can go and check out. That you can go and check out to have to see the entire working application. And the final prediction application in this case would be a recommendation-like system in which you can ask in queries like, can you show me messy goals from similar to what I watched last week? And then the application basically would do a similarity search based on the data that it has. So the application by itself knows what is your user ID, you have logged into it. Then you have historical, you know the video that you want to check to, so you have historical data in which you have like videos that you have watched last week that is stored in the application database. So based on that, we can do similarity searches. Similarity searches checking for similar videos that related to based on the video ID I have. And there's two approaches you can take. Like it is basically your option on like choosing what you want to do. You could do a post-filtering approach in which like you find similar goals by using similarity search and then filter out responses that you don't want. Or then you could do a pre-filtering approach in which you filter out things that you don't want and then you find similar goals. But the complexity here is that you would have to rewrite the data into another vector index for the similarity search. So it's a little bit more slower. But both of them are like options that you can do. The biggest complexity here is that right now, vector databases do not support filtering implicitly. So you would have to filter it manually. So these are approaches that you can do. And like putting it all into like one big picture, you have a video application. So that is basically using data state information. And you have an agent that uses an LLM system. You pass in the user IDs and video IDs that is used by the LLM system. And from the agent basically uses these user IDs to use tables from the feature store. These are basically tables from the feature store. The tables from the feature stores are like created by different sources. We have Whisper to encode we have a Whisper feature pipeline to encode the transcripts of the videos, and we could have a YOLOX to encode frames as features and things like that. But the basic idea here is to convey that once you have structured data, once you have data in a structured idea, a feature store can really help you inject meaningful information into the context of your LLMs. And just something that we are doing at HopsWorks right now is called Brewer. Brewer is basically a LLM assistant that can be used to create agents and machine learning pipelines. So this is an approach we have been taking with Brewer too, to generate much more meaningful pipelines and things like this. So this is something that you can check out. HopsWorks by itself is a machine learning AI lakehouse. HopsWorks, this is the complete HopsWorks stack. HopsWorks is a place where you can HopsWorks is an AI lakehouse you can use to deploy machine learning systems at scale and orchestrate it. So if you are more interested in learning about the Feature Store Summit, you can always join the HopsWorks. You can always join a Feature Store Summit that is happening on October. And we have a lot of big guys talking there. And our CEO also has written a book regarding building machine learning systems that gives you a very high-level overview of this one, and you can always scan the QR code to get a free copy of the book that will be released like in the coming weeks. So yeah, that is it from me. So if you guys have any questions, you can feel free.